Welcome, students. We're going to continue factoring today, and today we're going to be factoring things in the form x squared plus bx plus c. So for example, our goal will be to factor something like x squared plus 5x plus 6. Now, neither of the methods that we've learned so far are going to work here. There's not a GCF that we can pull out because x squared and 6 don't have anything in common. And we can't use grouping because there's 3 terms here, and for grouping we would need 4 terms. So neither of the methods that we know so far is sufficient, which means we're going to have to learn a new method. Now, for this method, we're going to start by doing some multiplications because this is going to help us find a pattern so I can show you exactly how this method works. So let's start with a few multiplications. I want to look at x minus 1 times x plus 5 first of all. Now this is a binomial times a binomial, so we can multiply by foiling. When we multiply the first terms, we get x squared. The outer terms give us 5x, the inner terms give us negative 1x, and the last terms give us negative 5. Then when we combine like terms, we end up with x squared and then plus 4x minus 5. We're going to do 2 more examples because usually having 3 examples is enough for us to see some patterns. The next example is going to be x minus 3 times x minus 3. This is also a binomial times a binomial, so we can also FOIL here. When we multiply the first terms, we get x squared. The outer terms, negative 3x. The inner terms, negative 3x. And the last terms, positive 9. And again, we can combine like terms, this time getting x squared minus 6x plus 9. All right, one more. Let's look at x plus 4 times x plus 2. Again, we have a binomial times a binomial, so we can use foiling. When we FOIL, we end up with x squared plus 2x plus 4x plus 8. And when we combine like terms, this gives us x squared plus 6x plus 8. All right. So I want to point out, every time we're multiplying a binomial like x plus m times another binomial, x plus n, in the end, we end up with something that starts out with x squared, and then we have a term that's some number times x, and then we have a constant term. This happens in every single case, and it's going to also work in the opposite order. If we have something in the form x squared plus a number times x plus a constant, and we want to factor it, the factored form is going to be x plus one number times x plus another number. Now, when we're given a trinomial like this to factor, we're actually given 2 pieces of information. We're given the numbers b and c. And I'll use my highlighter here. We're given the coefficient on x, and then we're also given the constant term. And our goal now is going to be to use that information to find these constants m and n in the factored form. Our goal is going to be figuring out what those numbers are. You can almost think of it as a game. We are spies, and we're given 2 pieces of information, 2 clues, the coefficient on the x and the constant, and we have to use those to solve the mystery of what these two numbers are in the binomials. And we do actually have enough information to figure this out because we can use patterns. So if we look at these problems, I want to focus on the coefficients of x, the 4, the -6, and the 6. Where does 4 come from if we start off with -1 and 5? In the same way that -6 comes from -3 and -3, and +6 comes from 4 and 2. Well, if you look at all of these, you can see that the coefficient on the x comes from adding these numbers. -1 plus 5 is 4, -3 plus -3 is -6, and 4 plus 2 is 6. So this coefficient b ends up being the sum of the numbers m and n. So b is the sum of m and n. This is one piece of information that we can use. But there's another piece of information, specifically these constant terms. How do you get -5 from -1 and 5? In the same way that 9 can come from -3 and -3, and 8 can come from 4 and 2. Well, all of these come from the products of these numbers. -1 times 5 is -5, -3 times -3 is 9, 4 times 2 is 8. So here, C is the product of m and n. And this is enough information for us to figure out what m and n are. Let's take a look at a couple of examples. I will show you how this works. Let's factor our first one, x squared plus 4x plus 3. Now this is in the same form as all of these examples up here. It's got an x squared and then a term with x and then a constant term. So we know that when we factor it, it should be the product of two binomials, x plus one number and x plus another number, just like all of these here. Now what we need to do is we need to find these constants. But we have two pieces of information that we can start with. First of all, we have this constant term 3, and we know that the constant term is the product of the two numbers. So we're looking for two numbers that have a product equal to 3. The other clue we have is this 4, and we know that we want the two numbers that have a sum of 4. So we're looking for two numbers that have a sum of 4. A product of 3 and a sum of 4. Now, some of you can do this in your heads. That's going to be a little bit harder when we've got bigger numbers. So in general, the strategy I use is I look at all the possibilities to get that product. So 3 is 1 times 3. It's also -1 times -3. And if you look, 1 times 3 is going to be the answer, because if you look at the sum, 1 plus 3, that gives you 4. So the two numbers we're looking for are 1 and 3. So our factored form is going to be x plus 1 times x plus 3. That's how it works. If you want to check to see that your answer is correct, you can multiply that out using FOIL and make sure that you get what you started with. If you want to do that, you can pause the video. But I'm going to move on to one more example. Let's factor, and this time we'll look at y squared minus 5y minus 24. Again, this is in the same form as all the others. We've got y as a variable instead of x, but we've got a y squared term, some number times y, and a constant. So we know that when we factor this, the answer is going to be a product of two binomials, each of which starts out with y, and now we need to find these constant terms. And we've got two clues to help us out here. This negative 24 has to be the product of those two numbers. So we're looking for two numbers that have a product of negative 24. And then we're looking for two numbers that have a sum of negative 5. Remember that that coefficient on the variable term is always going to be the sum. So we need two numbers that multiply to negative 24 and add up to negative 5. Now there's more possibilities here. 24 is negative 1 times 24, or negative 24 times 1. It's negative 2 times 12, or negative 12 times 2. Negative 3 times 8, or negative 8 times 3. And negative 4 times 6, or negative 6 times 4. There's 8 possibilities here that give us a product of negative 24, but only one of them gives us a sum of negative 5, specifically negative 8 and 3. So we know that our factored form is going to be y minus 8, because it was negative 8, and y plus 3, because it's positive 3, and that is our answer. Students generally find that after they do a few of these, they start to get the hang of it, and it becomes a little bit easier. So click on the link below, go through some of those videos, make sure that you understand how you're doing this, and then you'll be good to go.